Shalom. I'm very happy to describe here our research, the foliar application of boron to improve Hass avocado productivity. Avocado, as you probably know, has many commercial varieties. The most popular of them is Hass. Hass dominates the world industry, the global market, but the growers keep complaining of low yields and productivity problems, and that's where science can help. A few years ago, in 2016, Baldwin et al. Took off the pistils of avocado flowers and analyzed their mineral content and followed the development of the flowers. And they found out that pistils of flowers that set fruit had significantly higher levels of boron compared with pistils of flowers that did not set fruit. Boron is an essential nutrient. It is absorbed from the soil by the roots, and its prime function in the plants kingdom is building the cell wall. Boron deficiency is known to decrease vegetative growth in avocado and enhance environmental stress sensitivity. And it is negatively affecting the stigma-pollen interaction and the pollen germination, and eventually the fruit set. The suggested ranges for boron concentration in avocado leaves are between 50 to 100 ppm. A survey that was conducted in Israel among thousands of orchards found that in most of the cases, the leaves had lower levels of boron than the standard. You can see it here. So if we have a deficiency, we can add the boron. We're speaking about nutrition here. So adding a boron application by a foliar spray was found to increase yields in several fruit trees like olives, apples, pecan. And you can see here that in California, they applied boron to almond trees and it increased the yield. And in New Zealand, they applied boron to avocado trees and found an increase in the proportion of fruitlets remaining. So our aim was to test the effect of foliar boron spray over Hass reproductive development in commercial orchards. In order to do that, we detected Israeli Hass avocado orchards with low boron concentrations, and we applied the boron just before flowering and during the flowering season and investigated the pollen germination, the fruit set, and the yield. These are the orchards. You can see they're all located in the north of Israel, the Galil region. And you can see here that all of them had lower levels of boron, lower than the standard, far from 50 ppm. The products we applied were boric acid and Nutrivant. Nutrivant belongs to ICL. This is the normal formula of Nutrivant. But in the last year of the research, we gave a new formula of Nutrivant without potassium because the research that was conducted in Israel found that the avocado nectar is rich in potassium, and that's what makes it non-attractive for honeybees. So we didn't want to add more potassium, so this is the new formula. So we had the 4 treatments: boric acid, Nutrivant 3%, Nutrivant 2% that was given twice, before flowering and during flowering, and control. The other 2 boron treatments, the boric acid and the Nutrivant 3%, were given once before flowering. Each treatment contained 48 trees in 6 repetitions. The optimal boron concentration in flowers to get high avocado yields is about 50 to 65 ppm. So we tested the boron flower concentration in our research, and found out that in the control flowers we had about 35 ppm of boron, and the applications of boron raised this concentration to 45 to 65 ppm. Avocado flowers open themselves twice. In the first opening, they are in a female position. You can see here, this is the stigma. It is receptive here in the female position. After being pollinated or not, they close themselves. And after a few hours, they open again in the male position. And when they are in the male position, the stigma is not receptive. So in order to have fruits, we need the pollinator to take pollen grains from the male position flower and put it on the stigma of the female position flower. And you can see here that when we tested the pollen germination in the first year, we relied on the natural pollinators and sampled male position flowers. So they were supposed to be pollinated in their female position opening. But when we tested the pollen grains, we found that out of more than 1,000 sampled flowers, only 7 carried actually pollen grains, and only 1 of these grains germinated. So in the second year, we sampled the female position flowers, and we put them here, you can see, in agar wells, and we took anthers from Ettinger, the pollinizer variety, and hand pollinated the flowers. But when after incubation and fixation and staining, I found out that again, most of the flowers didn't carry any pollen grains. So in the last year, we again sampled the flowers in the female position, but we took them to the lab and pollinated them manually under the stereoscope. So I could see that 100% of the stigma carried pollen grains. And you can see that, yes, in the third year, we could see the positive effect of the boron treatment. The treated flowers had higher, significantly higher rate of flowers with germinating grains compared with the control. And we had more germinating pollen grains on the stigma compared to the control. So this is about the pollen germination. The next step was to make a fruitlet survey. We marked 20 inflorescences in each tree in the orchard, in the treated and the non-treated repetitions. And we counted the fruitlets in the inflorescences 3 times on May, June, and August. But there were several heat waves in the spring, and most of the fruitlets that were affected by the boron treatment dropped. So you can see here that in most cases, we didn't see the effect of boron in the fruitlet survey. Here and here, you can see that we have a positive effect of the boron treatment, but it isn't significant. So this is the early survey on May, and this is the late one in August. again, it is not significant. Regarding the final yield, you can see here that we have, in several occasions, we have a significant positive effect of the boron treatment. Here the boric acid, here the boric acid and the Nutrivant 3%. But in the other cases, we don't have an effective, significant effect. In several cases, it was even a negative effect. To summarize, the boron application indeed improved the pollen germination. It was good, but the productivity results were inconsistent along the years and in the different orchards. And part of the problem was the heat waves. So we suggest that maybe in order to try to cope with this problem, maybe a later boron application or combination between early and the late sprays can be more effective. The next step is to try and detect the penetration site of boron into the leaves. You know, when we spray the boron, it should penetrate through the trichome, the cuticle, the epidermis. So in order to optimize the application time, we try to have two treatments. Once during the night hours, when the stomata are closed and the formulation can stay longer on the leaf. And the second one, during the day, it dries quickly, but the stomata pores are open. So if the boron penetrates through the stomata, it is better to give the spray during the day. But if it's through other ways, maybe it is better to do it during night. That's it. I want to thank the collaborators of this research, the organizers of the conference, and you all for your time. You're welcome to question whatever you want. Thank you.